very sophisticated concept. Today's lecture. If you do not succeed to grasp the main idea, that will be described in today's lecture. Then you will have some difficulty to follow the next lecture. So, concentrate today's lecture. I can see that there is some students who are not present today. Okay, let's start with reviewing the last lecture. Okay, what we learned in the last lecture, can you remember what we learned during the last lecture? Anybody pick up the keyword or important message you got from the last lecture? What we learned in the last lecture? Okay, suppose you saw some movies. Can't you remember any impressive dialogue you got from the last movie? And can't you remember the impressive picture you got from the movie? Excitation. Okay. So excitation. That's nice. It's exciting, right? Excitation. What is excitation? Forcing. Oh, that's another very nice. Forcing. Before the last lecture, what we learned was the free vibration. As a free from what? Excitation. Or external force, or force. Okay? But we start to learn how the vibratory system would respond for the excitation. Okay? So we pick up the simple example that has spring and mass, and if you assume that there is assume that there is an excitation, and we denote the excitation is f of t because f represents the force and t is time. And we measure the response from this equilibrium position, and we denote the x of t. Okay? And we assume that f of t can be written as f0 cosine omega t. f0 is magnitude of excitation, and omega is the excitation frequency. Which is not same as omega n usually. Okay. And this could be a some representative model that mimics the vibration, for example, of suspension system of car, right? And K would be the stiffness of suspension system. We can measure it. How to measure it? We measure the force that can make unit displacement of suspension. Maybe we use your friend. Hey, why don't you guys sit up on the suspension system and measure the displacement? And then another guy, use another guy, and measure the displacement. And then we can measure the stiffness of the suspension system. And this gives us the governing equation. That can be written as mx double dot plus kx equal f0 cosine t. Okay. And then if we divide both terms by m, then this will give me omega n square x small f0 cosine omega t, where small f0 is capital F0 divided by f. Okay? And then we attempt to solve it. What we get is the solution can be written as, okay, come on in. xt is one term due to the what? Initial condition. Right? Initial condition. And that can be written as v0 over omega n sine omega n t plus another term is due to the initial condition of initial displacement, that is x0. And also there is another contribution from the excitation. And I have cosine omega t, cosine omega nt, and also I have n square minus omega square cosine omega t. Emphasize this that this is omega, this is omega n, this is omega n, and those are due to initial condition. Suppose the initial condition x0 and v0 is 0. Then what we have is simply the last term, and I call this x of t. Then what I have, if this is 0, then this is 0. Therefore I have f0 omega n square minus omega square. Then I have